Yeah, good afternoon. I hope you enjoyed your lunch. You probably heard this aphorism attributed to the ancient Greek philosopher Heraclitus, which says, "The only constant in life is change." Once again, it seems like new era is coming, and this time hitting us, software developers and architects. And to describe this new era, we just need two letters, AI. As we can hear all about here in OpenSlava, this too now brings a lot of buzz into our industry. So my name is Miroslav Merciak, and I work in this business for nearly 30 years. And last 19 years I spent in Siemens Healthineers, where my current position is software architect, and I also drive the software craft initiative. Maybe you know it also as software craftsmanship some years ago, and the people who practice it were called software craftsmen. But now, as I learned recently, the more suitable term, as we don't have a fireman but firefighter, then we don't have a craftsman but crafter. That's why I use this term throughout my presentation. Okay, so ones who can master the craft of software engineering will pave the path for everyone and become the leaders. This statement summarizes well our current understanding and expectations from software crafters. But will this hold in this new era of AI as well? Do we have to be alarmed? Is AI going to replace and do our job better? How our craft is going to change? And are we as software professionals prepared? So let's find the answers to those questions together. But as usual, we need to start with a little look back. Let's have a look at what we could call traditional software engineering. Might this be it? Yeah, we have requirements, we have design and testing and implementation. We have, do we really have documentation? We have release and installation. We have support and maintenance, and even marketing. Yeah, this well-known anecdote described quite well the issues we face in software engineering. And several software development lifecycle models were developed over the years that tried more or less successfully to overcome those issues, starting with waterfall, V-model, iterative, and incremental models. And so back in 2001, the group of 17 software developers met in Snowbird Ski Resort in Utah, where they discussed the lightweight methods of software development and formed so-called Agile Alliance. As a result of the discussions, the Manifesto for Agile Software Development was published, and those 4 sentences caused that other principles were derived. I think they mentioned 12 principles on their side, but I think that there is a lot more. And these include iterative and incremental, evolutionary approach with minimal upfront planning, efficient and face-to-face communication, and very short feedback cycles, and close collaboration with customers. This inspired a birth or improvement of many agile methods like extreme programming, lean, Kanban, Scrum, domain test-driven development. I'm sure we all heard about Robert C. Martin, or also known as Uncle Bob. He was one of the authors of Agile Manifesto. And it was in his keynote speech in Agile 2008 conference where he expressed his dissatisfaction with how the Agile developed over those years and suggested in his very emotional speech a fifth value, which he called craftsmanship over crap. 1 year later, Manifesto for Software Craftsmanship was published, which extends and challenges the statements of Agile Manifesto in order to raise the bar of professional software development by practicing it and helping others to learn the craft. It led to the propagation of principles like solid, dry, design patterns, clean code, clean architecture, and a lot more. By practicing those principles, developers were encouraged to strive for technical excellence and customer satisfaction. Of course, software craft is not only about writing a code. The two statements of Software Manifesto, Craftsmanship Manifesto, emphasize the self-perception of crafter as a valuable member of community of professionals. It is expected that well-crafted software can be delivered based on the shared knowledge and best practices, and the crafters are proud when they do the things right. The other two statements require that the crafters understand their customers, because they are the ones that define the value. The crafters are satisfied when they know how to do the right things. And so, how do we perceive the software crafter today? Yeah, okay, with Mr. Simpson Jr., we can say, as a software crafter, I will not write any bad code anymore. But why is that important, and is it enough? Software development is viewed as evolving engineering discipline. It is built on the knowledge gained over the years and confirmed by work of many practitioners. The knowledge is based upon the principles, patterns, heuristics, and practices. We could talk about clean code, design and architecture patterns, or code smells and refactoring techniques for hours. Why? Because this is our craft, basically. Crafters are the ones who know their craft. They have the skills and are able to provide results of high quality. They provide reasonable estimates and meet the commitments. They know when to say no, but try hard to say yes. Crafters are professionals. So while Agile was more focused on the processes, the main and most important idea of craftsmanship is quality. I agree with Emily Page, who in one of her educational videos stated that even if all other aspects of software craftsmanship are compromised, there is still one good idea behind it, and it's code quality, regardless if written by humans or generated by AI, is essential. Those 15 years ago, when Craftsmanship Manifesto was published, it was somehow empirically expected that the good code will result in easier and faster software development. Now we can take it as granted. According to study Code Red, the business impact of code quality by Adam Thornhill and Marcus Borg, in which they compared 39 proprietary production code bases using their code health metric to develop and to develop a new feature in a environment when you work with unhealthy code can be 2 to 9 times longer, and the number of defects can be up to 15 times higher than when your code is healthy. So, oops, no, sorry. So, Sandro Mancuso, in his book, The Software Craftsman, writes that software craftsmanship is a long journey to mastery. It is all about putting responsibility, professionalism, pragmatism, and pride back to the software development. In Siemens Healthineers, we try to build this culture of 3 Ps based on the best practices, openness, and sharing. Although we push hard to achieve our business goals, we also create a space where our developers can learn and experiment without a fear of failure. And we decided to extend the notion of quality beyond just a good code. We have built our software initiative, Software Craft initiative, on 3 pillars. Since the industry of medical devices is strictly regulated, our first pillar is platform expertise. Our engineers need to understand the physical principles of our devices, the patient workflows, cybersecurity aspects in regards to sensitive patient health information, and also environment where our devices are installed, operating, and maintained. So the quality starts with knowing your domain. We believe that only the design and code of high quality allow us to extend and maintain our devices. So the second pillar is code craftsmanship. This quality is essential, as we know. And our third pillar is test craftsmanship. By running and writing the tests regularly, we can better understand the requirements and needs of our customers. And yeah, the customers are what we are doing it for. So quality needs to be also validated. So to derive some conclusion, we can say together with Professor Raymond Fu from California Science and Technology University that the best engineers are not the ones who code the fastest, but the ones who think the deepest. We have seen in several presentations today already that coding maybe is not discipline that will be there without any changes, and that the crafters will just need to write a good code. Yeah? So there will be some shift necessary. Okay, now let's have a look at a few examples. The first, I selected a relatively old example from 2018, where, of course, no AI was involved, but it goes along well with the Code Red study I have presented earlier. This is a diagram of the scan controller component of our CT software. And what is interesting is this class on the right side. As you can see, it's one super class which was handling the logic of the interventional scans. And just a few numbers, 1,300 lines of code, no commands, no blanks, no braces, just the code. 41 methods in one class and 32 lines of code per method. I think it describes the complexity quite well, and it was really very difficult to maintain or extend some logic in the intervention module. Yeah, just by looking at this new design, we can identify the patterns that we used. On the left, there are interfaces and adapters to separate. In the middle, there is a state machine with its context. And on the right, there is a strategy used for different interventional scans. Yeah? Even though our new implementation has now 2,200 lines of code, a bit more, but we have 33 classes where the average length of a class is 65 lines, and average length of a method is 8 lines of code. So the complexity was reduced heavily, I would say. Yeah? And since we used interfaces and dependency injection principles, we could write a fully automated test for this. We have now over 400 tests running regularly. But what's the business impact? Here we can see, yeah? On the left side, orange bars shows that we were struggling with an average of 75 defects and customer complaints per year. And it is clearly seen that even if we tried and we fixed something, immediately something new was coming, like one fix generated one problem. Yeah? We could not get the numbers down. After the refactoring, actually we can see that we could fix the issues permanently. Numbers are going down. And I was also surprised that this year we only have 12 issues altogether with this component, which means that the worst number is 8 times higher than the best, which perfectly fits to the conclusions of Borg and Thornhill's study. My second example is a bit more recent. Since our projects are quite old, we were using and still use the NUnit-based test framework also for C++ code, which you can imagine how problems this can bring with the managed, unmanaged code and so on. So we decided to convert those tests to C++ pure test frameworks. We selected Catch2 or Google Test. And I take it as a challenge and try to do the conversion to Catch2 manually without using of AI, and then Google Test with usage of Copilot. As you can imagine, to start writing a test in Catch2, I first had to learn at least the basic of the framework, so I spent some time there. And then manually, I had to change the functions and assertion style to accommodate to this new framework. With the use of Copilot, I could immediately start the conversion. Just running a few prompts, Copilot was able to convert all the 50 tests in a few minutes. And then basically I used the time to get some explanation of the converted code and the framework basics. And afterwards, I was able to assess the correctness of the conversion. Yeah. As one could expect, doing it manually took 2.5 man-days. Doing it with help of Copilot, I could shrink this time to half of the man-day. Okay, so do you remember? The only constant in life is change. So if on the one side we have the traditional software crafter with his competence, skills, quality, and experience, what shall we put to the other side? How the crafter of the AI era could look like? You can say there is no difference. Well, let's have a closer look. Oops. Okay. As a crafters, we need to understand the AI. We need to know how it works. We have to see and understand what it is good at and where it's not good at, where it can help us. and we have to understand the biases and limitations of current AI systems. Using AI tools will become a standard in a daily life. Yeah? So writing a good prompts will be as important as writing a good code. Dividing the tasks between AI tools and people will become a factor of efficiency. Assessment of AI outputs will probably be the most important or one of the most important tasks of software crafters in AI era. It's inevitable to ensure the quality of the outputs, so this really becomes a key thing. And to adopt new AI advancements and adopt our daily routine accordingly will also be a very important thing, because it will bring the advantage to you and your team. It's us, software engineers, who have to master our craft. To be the crafter is not only about writing a good code anymore. We need to be ready to wear multiple hats and switch our roles as needed. I think it was also said in the previous presentations here in this nice conference that the task of the developer will now extend. Yeah? So job portfolio needs to include activities that cover predominantly human interaction. Understanding and clarification of user needs, yeah? Making tough decisions with responsibility and empathy, or taking the messy problem and guide the AI tools and teams towards the structured and meaningful outcome. Software crafters needs to be the architects who design the best solution, the developers who will use AI tools wisely to implement them, and the ethical technologists who ensure the solution is truly beneficial for people. There are also other aspects which we need to take into account. We, as software engineers, understand the AI better. We know its models, know its limitations and risks. We think of a bigger picture of building the systems that are maintainable, scalable, and reliable. And we are making the AI better. So it's still us, software engineers, who build the AI of tomorrow. And how we train, direct, supervise AI today will define the systems, technology, and society of tomorrow. So how the role of software developer needs to be transformed. I think that shift is clear from code writers to AI-augmented engineers. And which hats do we need to wear? As builders, we use AI as the coding partner, correct it as necessary, understand its output. To see that the generated code just compiles is not enough. Yeah? As validators, we assess the suitability of the solution, ensure the code quality, and also ethical aspects, like, for example, intellectual property or usage of open source software. And as orchestrators, we keep the bigger picture in mind. We manage the workload between AI tools and people. We collaborate and communicate and use the AI tools as one of our teammates. So finding the joy in what one is doing every day is the way to excellence. And that's what we should strive for, according to Craftsmanship Manifesto, yeah? And because there is no single Mr. Know-it-all craftsman who could teach us everything, let our curiosity be the guide. Maybe there are few things that can help you on this way. The first point is master the foundation. Yeah? You can argue, okay, why in this era when everything can be found and AI can do everything about this, yeah? But you cannot avoid the basics. We also heard that to work with AI means use a lot of data and algorithms and so on. So these basics like data structures, programming, concepts, and algorithms are as important as they ever were. There is no change about it. Go full stack across disciplines. Yeah? Widen your horizons. If you now have to cover more the human interactions, yeah? So be interested in project and product management, yeah? Design and architecture. Understanding how your work is contributing to the result is a source of satisfaction and pride. Think of systems like architects do. Yeah? Seek the design that is reliable, scalable, and long-term maintainable. For example, in healthcare, our software and hardware is used for years. And it means that to extend, to add a new feature or fix the bug should be as easy as possible. Practice collaboration and communication. Learn to work with people. Discussing the problem, implementing the solutions, validating the implementation, and connecting the experts is still the way and key to creating the value. Use AI as a partner who supports your creativity. The basics here are that you are the one who should concentrate on what and why. And AI is here to help you with how. And last but not least, stay adaptable, stay curious, because tools change, but principles last. So, is artificial intelligence going to replace software crafters? The answer is, of course, not. In fact, the AI tools will help us to increase the quality of our outputs, and as such, will help us to learn our craft easier. In the era of AI, software engineering is becoming the foundation of leadership. Crafters with their skills, competencies, quality, and experience not just adapt to the changes, but also help and lead the others, including AI. And thus, ones who can master the craft of software engineering will pave the path for everyone and become the leaders. And that's the bright future, isn't it? Thank you.
Thank you very much for the lecture. We actually have quite a lot of questions and still 10 minutes, so let's go through them. Okay, so the one with the most votes. So how was upper management convinced for engineers to spend time refactoring the code instead of implementing new features?
Yeah, that is a question that I get quite often. And I have to say that this was a case when the situation was really bad, because interventional modes in cities can usually have 3 different modes, and we could not use 2 of them, so there was only 1 left, and the customers really were angry about that. Yeah? So that was a business pressure to fix it as soon as possible and do it well. So in this case, it was not a big deal to persuade, but the question was, why didn't we do it earlier? Not only after the situation has come to that point that we could not use it anymore. And basically, it was the situation when even the damage of the reputation of the company was in stake. Yeah? So, yeah, that was easy. There are some other situations where maybe it's not that easy, because as usually with when manager hears the word refactoring, obvious question is why? Is there any problem, or is it not working? Yeah? So why do we want to touch it when it's working? So then there is, of course, some discussions are needed, and it also happened that we did some work in advance without letting management know, and then we persuade them by showing the prototypes and discussing the better solution and all the advantages that it brings. Hope it answered the question.
I hope so. Thank you very much. So let's go to the next one. In the era of AI implementing code instead of engineers, do you think code quality will be slowly neglected?
Yeah, that's also the thing we were discussing just recently with my colleagues in Germany. If we now say that, okay, AI is now able to replace a junior developer, does that mean that the quality will be, what will it do to quality? Will it be lower or higher or whatever? Yeah, so the fear is there. Some of our colleagues are really afraid that when you just let everything to be done by AI tools, how then junior developers will increase their seniority and will be able to assess the AI outputs. Yeah? And yes, I can feel this fear and I can share this fear with them to an extent, but that's just where we have to think about how to change the notion of the craftsmanship and what needs to be changed so that also the students or just people coming out from the universities were able to think in these categories. Like, it's not about writing a good code anymore, but it's about knowing what the good code is and why we consider it to be a good code. So this is back to one of my slides where I said it's about principles. And I hope that also the universities will help us with that people will be able to assess the AI outputs, since, as I said, I consider this to be one of the most important roles and things that software crafters need to do.
Thank you very much. Next question is actually going in the very similar direction. How do we help junior engineers grow properly to master craft in the AI assistance era?
That's a good question. Maybe we can use AI to that, since with the growth of these new models like, I don't know, ChatGPT 5 now or Claude Sonnet or whatever, it's quite easy to find some explanations of the code or of the principles. So maybe, but definitely it looks like, at least to me, that today the craftsmanship was put aside somehow. Yeah, we have AI tools, we have all this boom of agentic AI and whatever. So my answer would be bring that back. As Sandro Mancuso has said, yeah, bring that responsibility, pragmatism, professionalism back to the software development. It will give you a pride. I'm in the business for 30 years, and my younger colleagues always were looking at me like, oh, what are you talking about? When I told them, don't forget that computer science is the name. Yeah, computer science. It's not a code writing, it's not implementation, it's computer science. So if it's science, then it has its basic, it has its principles, and you have to know it. That's a difference between you as a student coming from the university and some coder, which I can find somewhere in the street and bring him in, yeah? So that's what we expect from the engineers. You know your craft, you know your science, and so it should be also your intention. Yeah, I am engineer. I have some craft that I want to master. It's not about writing a perfectly efficient code. Someone will write it with 5 lines, and I can do it with just 1 line of code. That's not the case. The case is you have a wide scale, wide number of activities you need to do in order to put it from the code to product, and we need to master all of that. Yeah, that's my point of view.
Thank you very much. Next one also feels a bit repetitive to the previous ones. How will the next generation of experts grow up if companies want experts and junior positions are being replaced by AI?
Yeah. First, that's only a question if the junior positions will be replaced by AI. A lot of people think that it might be. I would say we cannot afford it. We cannot let just junior position go and say we have, instead of it, we have AI. And then we only have seniors. Yeah? So it's just about how the work of junior software developer will be transformed. I think in the previous lecture here, it was said the same. Yeah? We cannot let the junior developers go. We just need to find a work that they have to do or what will help them. And I think the most important thing is learn the developers to concentrate on what and why. You have to understand, as I said, understand the domain, understand the customer needs, requirements, why it has to be done, why it has to be done this way, what are the benefits, doing some analysis, evaluating the stuff. Yeah, and then you can just ask AI to help you with how can I implement it in this framework, or using even agentic AI now to do the stuff. Yeah? But the analytical and creative work and communication with experts is still with humans. AI will not do a decision for you, at least not now.
Wonderful, thank you very much. We actually have still a lot of exciting questions, but seems like our time is over. So whoever actually wants to have some questions answered, I highly encourage you to actually grab Miroslav somewhere during the break. Miroslav, thank you so much for your time.
Thank
Thanks,
you
guys.
for having me here.